Hello, everybody. Welcome back to Check Ride Chat again. My name is Wally.
I'm Jason.
Today, we're going to talk about interpreting some weather charts. Basically, well, I don't know if you call them charts. They're not really charts. But we're going to talk about
Data.
METARs. We're going to talk about taps, and we're going to throw in some other little nuggets. We're going to talk about raw data. Or data. We're going to talk about reading METARs. We're going to talk about reading TAFs, and what is a METAR? It's the weather report of what's going on right now. What is a TAF? Terminal area forecast. Okay, and I know most of you, including me, I do use an electronic flight bag. Okay, let's get that out there right now. I do not use paper sectionals. I haven't used paper sectionals in a long time. Could I use paper sectionals? Absolutely, I could.
I have paper sectionals. I can't say they're to date, but I have them.
Yeah, but we're going to talk about reading the raw data. Now, I know in ForeFlight or Garmin Pilot, whatever you might use for an EFB,
anything, honestly. You can anything. There's separate apps. There's stuff online. But continue your point.
You can decode this stuff. You don't have to know how to read this stuff.
There's typically a button, a switch, or whatever that it's either decode or translate. Are the two functions. That's great, but
I was going to say there's a T-shirt that I love that I saw someone wearing one time, and it had decoded weather on it, and it said, if you can read this, thank a teacher. And then it had non-decoded a METAR, and it said, if you can read this, thank a flight instructor.
True.
So anyway, so that's kind of a cool thing. So why do we need to know how to be able to read the raw data? Well, Jason and I, we both fly big airplanes, and we get pushback from this. We don't care how it's done at the airlines, but we're going to tell you how it's done at the airlines a little bit. We get weather all the time, and it is not decoded. When we fly ETOPS flights, which is the long haul stuff, we've got to keep track of potential alternates, and somewhere before we enter this certain type of airspace, from our dispatcher, we're going to get a message with what we call our ETOPS weather, and it'll come across our printer, and we've got to make sure that those alternates that we have are suitable for us to go to if we need to go to. Is that stuff decoded, Jason?
Nope.
So it's 2 a.m. and your body is saying, man, it's time to go to bed or drink another 3 cups of coffee or something, and then this decoded weather comes across, and we've got to be able to read. Raw. Absolutely. Weather. Yeah, I said decoded. It is the raw weather. We've got to be able to read. We've got to be able to read it. So, we're at probably a fairly high level of flying. We've got to be able to do this.
It's the basics, right? So, I'll add to that. So Wally now, he just went to the 787. I'm still on the 7576. But it doesn't matter. If anybody, let's use ForeFlight as an example. You plan across country from A to B. You send it to your flights, and then you hit the briefing, right? It is going to take point A to point B, and it's going to draw a silver circle around that route and give you every source of weather, every chart, every METAR, every TAF, every NOTAM, even NOTAMs for this matter. This is reading raw. My point is, around this little cube, this circle, this hot dog looking thing, you have every source of weather in that. Now, that's just for your Cessna 172 or Archer or Seminole 310, whatever it might be. That's just for that. That's for your anywhere, whatever long a flight. Now, amplify that out. The longest stuff we do in the 7.6 is pretty much 11:30, 11:50 if you're kind of Germany to Houston type thing. 787, you are pulling 15, 18-hour legs. Now, translate that. That's, let's say, Houston to Munich, right? Go put that silver thing around that entire flight.
Right.
Could you imagine how big our weather package would be if everything was quote unquote translated.
Right.
It would be thousands of pages.
Right.
So the takeaway is this, and we're going to put some graphics up on there. Just METARs and TAFs, just stick with it. Even NOTAMs, they all have these translated options, translated, decoded options. You just tap and it says translate or decode, one of the two. It depends on your source, right? Fine, great. What we're saying, yeah, use it, but you really should be using raw data weather.
Right.
With that being said, your private pilot written, your instrument written, all your written tests, there is no raw data. There is no translated, decoded data on those tests. Everything is raw. You are quizzed, you are tested at the source, which is raw.
Yeah.
You really should be reading raw data. My advice, I think Wally's advice, most people would tell you, fine, use the translated, use the decode method to help yourself learn how to read raw weather. There's a METAR decoder issued by aviationweather.gov. Most students in the flight schools have that document in one of their for-flight documents. And when you look something up and find that source, you're going to learn it, you're going to retain it. So try to read the raw weather. If you can't, I would suggest looking at the decoder table. If you can't, then use translated or the decoder method. And if you still can't figure it out, maybe ask. When you ask somebody an answer, that's like the easiest way to get it, meaning you're most likely not going to retain it. So do the little bit of work, do the little bit of effort. I went back when I became a DPE just to make sure I was doing kind of the right thing. I actually went back and took a private pilot written, an instrument written, a commercial written, just to make sure things kind of hadn't really changed. And guess what? They haven't. So how I was trained, stalls have changed, slow flights have changed, things like that. But the guts of it, that is all still the same. So raw weather, that's a big deal. So
did you pass?
I didn't go to pay. I'm not gonna. Okay. There's no reason to do that. I did it through Sporties.
All right.
But did I pass? Yes.
Yeah.
So, and I kind of learned a couple things, or not learned. It brought back to the foreground stuff that is rarely used.
Definitely.
So, what is a METAR? A METAR is what? A METAR is weather. It's the ATIS, it's the ASOS, AWOS, whatever it might be. It's the weather that's issued typically, and yes, I know ASOS, and that's minute weather, I get it. But the point is, it's once an hour.
Yeah.
Right?
Yes.
So METARs are issued once an hour unless something has changed, something significant.
Right.
And then they issue what's called a SPECI, which is a special. If the weather has changed, they're going to update that weather. Here's a question. How much area, what is covered by a METAR? What does that METAR, how big of an area does that cover? The answer is it's the airport. It's the airport, and that's it. It's the surface of the airport, right? So coming to the next one, it's the TAF. TAFs are valid 24 to 30 hours. They're updated every 6 hours, which if you go 6 times 4, that's 4 times a day, so that's 24 hours. So they're updated 4 times a day every 6 hours. They're valid for 24 to 30. What area does that cover?
The name of it is the terminal area.
So what's a terminal? It's 4 to 5 miles around the field.
Right.
So the METAR is the field itself. The TAF is loosely is kind of the airspace.
Yeah.
And then the next big jump is actually the area forecast, which is depicted FA. And it's funny, it goes from the airport to a couple miles to like massive, like the south central U.S. There's nothing kind of in between. That's also why it's very, very important to get METARs and TAFs along your route, because what's happening right here doesn't necessarily translate what's going on kind of 10 miles away. Right.
And ForeFlight does a really nice thing when you put in your route. It's at least, I don't know, maybe mine is configured this way, but it's color coded.
Oh, the color codes are awesome. Green, red, blue,
green
pink.
dots.
Yeah, it's great.
Green dots along my way. Oh, there's a couple of blue dots south of my route. Okay, what's there? Okay, well.
So, I can't believe I'm about to say this out loud. It's just like autopilots.
Yeah.
So if you saw green dots, are you really? You should, because there's valuable information down there. But it just gave you the answer without you looking at anything, right? So do yourself a favor. Actually read the weather. Know what's going on.
Yeah.
Look at the forecast winds so you can have a plan of action when you arrive at that airport. You can plan hopefully the arriving runway. You can plan from the runway, how am I going to get from this runway to whatever FBO. That's all. I would do all this on the ground. That's just simply flight planning. We do it United. We do it all the time.
And those forecasts we mentioned are issued 4 times a day. The times are nice, easy numbers: 6, 12, 18, 24. Zulu time. So,
ooh, what's Zulu?
Yeah, well, that's something else to add into your repertoire. I just had a young man just the other day on an instrument rating that, boy, he struggled immensely. I went out and took about a 10-minute coffee break while he did whatever he did in a room, whether it was phone a friend or whatever. He got the answer. He finally got the answer. My question with him, we were supposed to depart at 1500 local time, and I asked him what that was in Zulu time, and he said 1500. I said, so local time is Zulu time, and he really, I don't think he understood the concept.
There's a reason everything is issued in Zulu time. It's simply to take away what time zone am I in.
Yes.
It puts everybody anywhere in the world on the same page.
Yeah, absolutely.
That's it. So figure it. That's a whole, not a separate topic, but figure out what Zulu time is. All right, we got METAR's task, the importance of studying raw. We'll hopefully put up where you can get the METAR decoder chart.
Yeah.
We're we'll put up some graphics on, this is what this looks like specifically on ForeFlight raw versus decoded, especially things like that. Let's talk about winds and temps aloft.
Okay.
So over these topics that we're talking about now, these are things that we see that a lot of applicants typically just simply struggle with.
Yeah.
So winds and temps aloft. So Wally's going to upload this in a second. But first things first. So winds and temps aloft. So one of the questions in the ACS is, what is acceptable weather sources, right?
Yeah.
The Aviation Weather Center, NOAA, those are all, ForeFlight, those are all good. An app on your phone, what is the source of that? I can't really answer for that. So you need to know where to go for good, solid weather data. But we're going to put up a graphic now. Here's a winds and temps aloft. So first thing first, this whole, it's a bunch of numbers, right? This whole thing are these winds true or are they magnetic?
They are true winds.
They are true.
Anything issued for winds aloft are true winds. We talked about this in the sectional thing, the difference in magnetic and true. And again, down here in Houston, Texas, it's about 1.5 degrees difference, so it's not that big a deal. But you get up closer to the poles, and that you maybe
skews it quite a bit.
Yeah.
So where we're going with this, it's true. So you're going to take these true winds, and when you put this into your flight plan, you are taking these true, everything is being converted to your magnetic course. So it's true, 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 and then you're switching things to magnetic. You fly a magnetic heading, right? You have a magnetic compass in your aircraft. So when you're flying magnetic. But when you're computing through the raw data, everything is true. You're translating true over to magnetic because that's what you have in the cockpit. So these written down winds on this winds and temps aloft, those are true. What kind of wind is a METAR, Wally?
METAR winds are magnetic.
Why is that?
Well, you're on the ground. It's at the airport. That runway heading
is magnetic.
So
nobody wants you to do mental math in your head. Where am I? What's my variation?
Right.
So you have a crosswind, 25 gust 45 or whatever it might be. Hold on. So where's my wind coming from? No, surface winds are magnetic because nobody should be computing anything in your head. It's what you're flying, the winds are there, it's done for you. Surface winds are magnetic. Winds and temps aloft are true because you have time to basically translate that. All right, so back to this. Okay, so he's going to have a couple things highlighted. That there's temps, winds and temps aloft.
Right.
What is this temperature in?
It's in Celsius.
These are Celsius.
Yeah.
It's not Fahrenheit, right? So these temperatures are Celsius. If you look on the very, very top, temperatures are negative above 240.
Right.
So it's always going to be negative. There's no reason to put the minus sign. All right, so everything above 24 is negative, although it doesn't have the negative sign. So sometimes just read the charts. The altitudes 3, 6, 9, 12, 18, 24, 30, 34, 39. Those are the altitudes at this. And so we're going to go down. We're looking at SSM. So that wind and how a wind temps aloft chart works, the first two numbers are wind direction. The second two numbers are wind velocity. The third two numbers, if there are a third two numbers, that is your temperature. So at 3,000 feet, there are no temps. So it's 2 for the direction, 2 for the velocity. So at SSM at 3,000 feet, the wind is 230 at 17 knots. It is not, the wind is 2, does this even sound right? Have you ever even heard of a METAR that says this? Wind's 231 at 7. No. The winds are always two directions. Add a 0, right, either before or after. But it's 230 at 17. Let me see if I can't find a good example on that. And I don't really, I was looking for the single digits, like the zeros. Anyway, so that's that. On the same column, if you go up, GCK, there's nothing on GCK at 3,000. There's nothing at GLD at 3,000. Does that mean it's broken? Why is there nothing there?
Broken. It means I'm going to tell you right there. GCK and GLD have a higher elevation.
So the elevation of the field elevation is within 1,500 feet of the reported altitude.
Right.
So if you simply go look up GCK, it's going to be within 1,500 feet of 3,000 feet, which is the reported altitude. So what winds would you use there for GCK?
Surface winds.
You would use the surface winds.
The METARs.
Correct. So blank, it's not broken, it's just within 1,500 feet of field elevation. GFK, 9900. Winds are
990 degrees at 0 knots.
Yeah, because that makes sense,
that
right?
Doesn't make sense.
That doesn't make sense at all.
Doesn't make sense.
So 9900, winds are light and variable.
Right.
Right? So that makes sense, right? 00, that's 0 knots, that's calm. But what the heck is 99? It's the winds are light and variable. There is no specified direction. They're just very, very light, and they're negligible.
Right.
All right.
Right.
Let's go up to the 9,000 foot column. DSM, which is Des Moines. Winds are 270 at 36 knots. Temperature is positive 7 degrees Celsius. So again, 222. First 2 is direction. Second 2 is velocity. Third 2 is temperature. So 270 at 36 knots plus 7 degrees Celsius.
And why do we care about the temperature? Icing, maybe. Okay, if you're in the clouds, obviously the temperature is going to be. You got to have moisture and you got to have freezing temperatures.
So on that note, let's scroll up. So SPI, I don't know where that is. Do you?
No,
it doesn't. You could look it up if you want. That's just the airport. That's the region. Winds at 12,000 feet, 270 at 32 knots. And the temperature is plus 1 degrees Celsius.
All right, so I'm concerned.
If there was visible moisture, or if I was in clouds, heck yeah, I would be concerned about structural icing, probably carb icing. You're right on that threshold.
Yeah.
All right. Let's close out. Last thing. So GFK, let's go down to the 34,000 foot column. 790058.
Wow.
What runway is what direction is zero? Is that direction 079?
I don't think so.
I don't think so.
I don't think so.
No. So 79. If you have anything over 36, right? Because there's no direction beyond 360. That's the highest number. They can clearly tell you it's any direction you want. But if you have anything over 36, what they do is they add 50 to it. And what that's telling you, that is code that your wind, your second two, is over 100 knots. Because again, there's only 6 spots.
Right.
So they can't put that third digit for the wind. So what you would do is you would subtract 50 from the first two numbers. So what's 79 minus 50?
29.
That's 29. So that wind is
290.
The middle two numbers are 00.
Right.
You're going to add 100 to whatever that number is. So
Yes.
0 plus 100 is 100.
Yeah.
So it's 290, 100 knots. And again, we're above that 24, as mentioned earlier, negative 58 degrees. Let's see if I can't.
Now,
find another one.
just to give you
There's
a little
one.
bit way of helping you out with that, if you're just totally confused at the 79, take a look at the wind below it. And
That's what I was
look
gonna
at
say.
the wind right below it. In that case, that's an easy one. It's 28 at 97. So
Yeah,
the
it's
wind,
going up. I was going to say the same thing.
Yeah.
Like, go to the left. That's a normal number.
Yeah.
And if you just trend it over, the winds went from the whole column. It went from light and variable to 15 to 29 to 39 to 64 to 89 to 97 to 100, right? And then it actually dropped back down to 96. So potentially a better example of this, if we scroll up to San Simone, SSM?
I think so.
That's a VOR, like Chicago area. SSM at 34,000 feet, there's a 79116, 58. So 79 minus 50, that's very easy. It's just 7 minus 5. So that's 290 at, again, we're going to add 100.
116.
So what's 100 plus 16? 116 minus 58, negative 58 Celsius.
Yeah.
So there's your winds and temps aloft, right? This, I guarantee you, is on your private pilot written, your instrument written, and your commercial written. All these raw data things.
And your ATP written.
And your ATP. It's raw data. It's there. Hopefully this helped giving you a handful of examples.
And when are winds aloft issued? They're issued 4 times a day. You'd think they'd be issued maybe the same time as the forecast, but they're not. All you got to do on this is remember 10-4, good buddy. 10 and 4.
10-4, Kojak, 10-4.
10
That's
and
when we
4.
update our winds at the airline. So
Yeah.
10-4, 10 and 4.
So 0400, 1000, 1600, 2200 Zulu time is when the new winds and temperatures.
And again,
will come out.
Zulu, because it's standard, they
Right.
can't translate this to every single time zone across the world. So
Right.
that Zulu, that makes everything, the official word in aviation is standard,
Yeah.
right? So they have to put, that's the standard. This is when we do it. No matter where you are in the world, you know when it is taking place.
Yeah.
Ergo, that's why you have to kind of know what Zulu time is, because most everything is translated into Zulu.
Yeah.
Our flight plans, we have a local departure time and a Zulu departure time, because like that's local, that's good to know. Half the time, this sounds weird and funny, I don't know what time zone I'm in.
Oh, I
So
no
when
idea.
if
No idea.
I'm international, I actually will change my watch face simply to Zulu,
Yeah.
because that's what we function in.
Yeah.
Food for thought on that. All right, so we've talked about METARs, TAFs, winds, temps aloft. Again, a true reason. We found ForeFlight. We screenshotted a picture on that. Even the winds aloft, everything is translated.
Yeah.
I get it. I do. I get it. The translated and raw, it's available. Don't be that lazy guy, right? The standard is the raw. right? So do yourself a favor and learn the raw weather, learn the raw winds, learn how to read, learn how to translate that in your head. It's actually much, much quicker. That's why, this is a horrible analogy, that's why court reporters, do the freehand, or what's that called?
I know.
You know what I'm talking about, where they type, it's this symbol means this word. It's just, it's much, much quicker when you read that. All right, here's one. We're going to close on this. And this seems to be, people know when you can do it. They know when you can't do it. But a lot of people have no idea what it actually is. And we're going to talk about what special VFR is.
Yeah.
So what is special VFR? So can a student pilot do it? Nope. Can a private pilot do it? Heck yeah, they can.
Yes.
Right?
Yes.
Can a private pilot do it at night?
Maybe. If.
No. If. And that's where, when you give instrument check rides, one of the very first questions in the ACS, or the first topics, is please describe privileges and limitations. What can you do? What can't you do? And I love it. And the follow-on question, when they bring it up, I always ask this. They'll say, I can do, as an instrument pilot, I can do special VFR at night. And I go, awesome. Can you tell me what special VFR is, please? Would you mind describing that? And 9 out of 10 answers is, well, I can do it at night. That's great. That's not what I asked.
Yeah.
So let's get into this, and it's very, very easy, and I'm going to explain. So special VFR, first things first. Yes, you have to be instrument rated to do it at night. And I'm probably going to tell you the reason why, or if you can put 2 and 2 together, you're going to figure it out. Special VFR lowers the visibility, the required visibility, and you're still VFR. It lowers it to 1 mile, 1 statute mile visibility, and you have to remain clear of clouds.
Yes. That
is special VFR. It lowers your VFR weathermen's to 1 mile clear of clouds. Now, daytime. Okay, I can probably see those clouds. Meaning you need 1 mile published viz, and just don't touch a cloud. Don't go. Can you graze it with a wingtip? Great. You can still see, right? That's fine. Just don't go in a cloud. So fast forward this to night. Can you see a cloud at night?
No, you can't.
If it's a full moon, maybe, but typically no, right? So that's where, if you get into the weeds and it gets bad and hairy, you can pick up a local IFR and kind of get out of jail free.
Right.
But ergo, you have to be instrument rated to go up at night, because you simply just can't see clouds. It would be very, very, very difficult.
Yeah.
Now, it lowers, again, 1 mile clear of clouds. So can you do special VFR in class Delta, Wally?
Absolutely.
Can you do special VFR in class Charlie, Wally?
Absolutely.
How about any Bravo in the country?
I haven't found any.
No. So why on earth, and this is getting to the understanding what special VFR actually is, why on earth does every single Bravo in the country, and he's going to put some up, say right at the top on the VFR sectional, when you read it, it says no SVFR. So no special VFR allowed. So this is understanding what special VFR actually is. So here's the takeaway. Special VFR. 1 mile clear of clouds. Right? So published visibility. If they're reporting half-mile viz, you're not getting it.
Right.
Like, it has to be a minimum of 1 mile.
Yeah.
So special VFR, 1 mile clear of clouds. You, the pilot, have to ask for it. So Delta and Charlie, you have to request special VFR. The tower has to grant special VFR. It is not a given. They can tell you no. You have to ask. They have to grant. They're going to give you a beacon code. And here's why there's no special VFR in Bravo. You can be the only one in the airspace. So they can, I have been told, they can make exceptions. If you're going east and some guy's coming in, from the west, that's you're split far enough. But you can be the only person in the airspace. So what that means, so Delta, that's a 4 mile radius.
Right.
You're going to be out of that airspace pretty quick.
Couple minutes.
Charlie, same thing. You have the surface, which is 5, and then you've got the second shelf. But if you stay low, again, you're out of Charlie pretty quick.
Yeah.
Bravo. They are not about to shut down Houston or Dallas or Chicago or New York, any of the New Yorks. They're not shutting that down
Right.
because you just want to go fly
Yeah.
in those kind of conditions. Again, you can imagine how big the upside down wedding cake of Bravo is,
Yeah.
right?
Yeah.
Okay, Mr. Cessna,
Yeah.
we're going to hold every
Right.
American, United, British Airways, Lufthansa plane just so you can go skirt the cloud.
Right.
No,
Right.
they're not going to do that. But that's why there's no special VFR Bravos.
Yeah.
And again, so special VFR, it lowers my visibility, my required, my minimums, to 1 mile clear clouds. Pilot must ask, tower must grant, and then you can be the only one in the airspace.
Yeah.
Right? Why you want to go special VFR? I've done it multiple times.
Yeah.
It's you can sometimes get out quicker, especially if it is what it is. Would I tell a private pilot to do that? No, not a newly minted one. If you
No.
happen to be a private pilot with thousands of hours or hundreds of hours and you're super comfortable, that's all you.
Yeah.
All we're doing is, I love asking the question, tell me your privileges. And then they know what special VFR, that I can do it, but they have no idea how to define it.
Yeah.
So that goes what we said from an earlier show. There's the rote memorization. Yeah, I can do this. Well, can you tell me what it is? And most applicants have no idea.
Special VFR is a tool. It's a tool that's in your toolbox. You go
It is.
out and they're calling 4 miles visibility. You start up and all of a sudden you're taxiing out, and tower just says, field just went IFR 2.5 miles visibility, and I don't know, whatever the obstruction is, and you've got a cross country trip. You're going 200 miles away. You know the weather's great. The temperature is warming up. You know it's going to burn off.
I wouldn't do the entire cross country.
Oh no, absolutely not.
That's not
No,
what we're saying.
no.
It's a tool in
No.
the sense, like yesterday or 2 days ago in Conroe, it was gorgeous. There was not a cloud in the sky, calm winds. We go out to take the flight, and I'm like, where'd this come from?
Yep.
And it was
Yep.
still VFR, and it was coming from the west,
Yeah.
going east. So literally 5 miles away to the east is that severe clear.
Right.
But it was slowly lowering.
Right.
It's scenarios that we're not telling. It's a tool. We're not saying go skirt and scud run at
Right.
1 mile clear clouds. It's a way to kind of get out into better weather without having to file, without having the lineups, without having it's a tool.
Yeah.
So
Yeah.
use that tool, but the takeaway of this per se lesson is that is what special VFR is.
Yeah.
That's what it means, and that's how you use it.
Yeah. I used to work at a place that did pipeline patrol, and our pipeline pilots, I was a lineman. This is a long time ago. Our pipeline pilots used to take off during the winter, almost every morning, and get a special VFR out of the airspace, because they're going to go fly at 300 feet along a pipeline and patrol.
And 5 minutes away, 10 minutes away is severe clear.
Right.
Right. So don't, again, plan for the mission.
Yeah.
Right. Know the rules.
Yeah.
And know what rules you can, and just know the rules, and you
Right.
can do hopefully what you need to do.
Right.
Good.
All right, so we've talked about tasks, we talked about METARs, winds aloft, and a little bit of special VFR. You know, we know you have tools to decode all this stuff, but really, and something else that we're doing in some of these, we're actually, we're giving you a little bit of history of aviation, how the way things used to be. We're not advocating that we need to do it that way. We're not saying go fly around in an open cockpit biplane wearing a leather helmet and goggles.
It's cold, man.
We're not saying that, but we are kind of telling you the way things used to be. When we say back in the day it was this way, we're just trying to, I just remember my dad telling me about using range navigation. I was fascinated by
Loran?
No, range.
Oh.
And well, we can talk about Loran, we can talk about all kinds of stuff, but
I still want to find, I think they still exist. They had like huge big arrows
Yeah.
like on the ground.
Yeah, yeah.
I would love to go find
Yeah.
one of
Yeah.
those. Like go that way.
I want to find a working ADF.
Yeah, that. Good luck on that one.
Yeah, yeah.
Um,
But anyway, so don't be offended by us trying to tell you the way things used to be. We are trying to build a foundation for you, and hopefully you get something out of this.
So let's close on that. We're trying to build that foundation. We're trying to make you more situationally aware, more self-aware, just a better kind of all-around pilot. And with that being said, let's use GPSs, autopilots, etc. Great. Not every airplane has a GPS. Not every plane has an autopilot. If you have those tools, use those tools. That's fine. But you can't fly an airplane just simply knowing how to use a GPS. You still need to stick and rudder that airplane. You still need the fundamentals
Yes.
of flying. You can't just, I have an autopilot. Great.
Yeah.
It doesn't, you still need to know how to fly, and that's kind of the weather. You should be able to read raw data weather.
Yeah.
There's all these other tools they're making it easier, and it's awesome. But again, the core of this is raw data weather, and that's kind of what we're getting at.
Kind of like reading an analog clock. I mean, a lot of people today they cannot read a clock. I know my kids struggled with it, and they finally said, okay, well, I got to learn how to read a clock.
Reading 24-hour time.
Yeah.
You're gonna hate if you struggle with it. You're gonna hate it. Set your watch. Set your TV, your microwave, your stove. Set your car clock to 24-hour, and in about 1 to 2 weeks, you're gonna know it, and that's all you're ever gonna want.
You are.
Right. So force yourself to do it, and you'll be better off down the road.
So again, hit subscribe down there. Tell your friends about us. Here's our email addresses: wally@checkridechat.com, jason@checkridechat.com. You want to contact us directly, just shoot us an email. We will respond. And I guess that's it for today, all right?
Cool. Y'all have a good one.
We'll see you next time.